I'm CK. Tonight we have another little kit from eBay, a soldering project do-it-yourself thing. This happens to be a ultrasonic rangefinder, and it's a little practice kit for people to get used to soldering, as well as having some new interesting things about electronics to learn. So hope you enjoy it. So let's see what's in the bag. Again, the label is not too descriptive. It does not have URL, just a UPC code, and I don't think the UPC goes anywhere. But let's see what we got. Here's the main circuit board, and it looks pretty good. Looks like we've got some switches here, power connector here. There's a big IC here with some components stuffed underneath it. Various conditioning resistors, and then it looks like a 3-digit numeric display. Nothing soldered on the back. So that'll be the motherboard for our project. Here's the interesting bit. These are two ultrasonic transceivers, and it's got a timing crystal on it too. Let me see if I can see what the frequency on that is. It doesn't have a frequency number listed on it, which is unusual. And then a 4-pin connector with VCC voltage, trigger, echo, and ground. So there's your voltage in and ground, and pulse that to trigger a ultrasonic blast, and then pick up the echo on that pin. I think. I'm just speculating right now. Another USB cable, because you can't have too many. Oh, this is cute. They actually took the USB cable and just took it straight to a power barrel connector. And here is a battery tray for 3 AA size batteries, and stuck to it as usual. Let me get my tweezers. There's some transistors. So it'll be 1.5, 3, 4.5. So 4.5, 5 volts. That's why they can run it off USB also. And here's the big IC. It's an STC. I think I've used this one before in something. And it's got the back. And it's got, I think this one has, this chip has 64 kilobytes of static RAM for embedded programs. So this is already pre-programmed to be able to read and trigger the sensors and read the results back. Now here are a bunch of resistors, disc capacitors, another transistor, and the ubiquitous barrel buzzer, and a little button cap, switch cap, however you want to call it. It goes on this. And then another switch, a couple of more transistors, and something I don't know what it is quite yet. Oh, it's another timing crystal, and this one is 12 megahertz. So that's all the parts. Now, as you can see, The clever observer will note there is no display for this. So I don't really know. Oh, there it is. Never mind. Turn the foam over and you'll see it. So it looks like it's all here. It looks like it's going to be a relatively straightforward build. And I'm all ready to go. But I do want to cycle the cameras on and off once. Oh, one other thing. I'm sorry. Let me not get ahead of myself. There is a URL on the board. It is www.52dz-diy.com. So I'm going to take a quick look at that. It's resolving. It's not secure, but it's resolving, so they don't have an SSL cert. Considering that it took me 20 years to get an SSL cert on my domain, I'm not going to criticize anybody else for that. So the website's all in Chinese. Let me bring it under so you can get a quick look. So I can't read any of it, of course, but it looks like it's got industrial equipment, robotics, do-it-yourself stuff, some general do-it-yourself electronics kits like this one, and looks like a fine place, except I can't read it. And clicking around at random gives me some interesting stuff. Here's a little light tower thing. Ooh, that looks like it might be fun. Maybe I'll look more at that later. And this time I remembered to bring my fancy new timer up so we can get a more accurate timing of the build. And as you saw from their website, I didn't see any build instructions, but I don't believe we will need them. So let's dive in. We'll do, of course, in typical fashion, we'll do the resistors first. So what's the most? All these 1K resistors. It's just a bunch of 1Ks, then a few 4K7s. And of course they're easy to differentiate since one is brown and 4 is yellow. So let me get these all socketed in. Oh, and actually start the timer. That's a good idea. Okay, there's all the 1Ks I can see, but I do have one left over, which might just be for fun or a spare, but I don't see any other place for a 1K resistor. Well, we'll see what happens when we do the 4.7s and see if they provided one extra there too. Now, I haven't made any comments about the board itself yet, but, and you may notice, I'm sorry, we ended up with 2 extra 4K7s. I haven't commented on the board. The board's good quality. The stenciling or silk screening is very crisp and clear. The holes are plated through the board. If you'll notice on the back, the component distance is nice. It's not all crammed together. You can see the traces, so someone can see all the signal lines coming off the microcontroller going through the resistors, which are going in to the display inputs. So a learner, a beginner, can actually follow the electrical flow and see how things are actually working. See why, where the signals coming out of the microprocessor are going, where the signals coming in from the ultrasonic transducers, where they're coming. And so this board is laid out very well for a good investigative beginning type board. So now I'm going to put the capacitors on. Let's see what we've got. We've got we've got one electrolytic, which I believe goes right here. And I think it's going to have to, it's a 10 microfarad, and that's it. So I think this needs to lie down, or lay down, however you want to say it, because we're going to have the processor microcontroller on top of it. So I have to figure out which way I want to bend it down. I would like to go this way, but I don't have enough room for that, so it looks like I'm going to have to go this way, and that just puts it kind of side by side, the resistor there, which I never really like, because resistors imply heat, and there's not much room there. That's a pretty, I'm going to call that a little bit of a shoddy design decision, to not give me enough space to lay that electrolytic down solidly, but I'm going to solder this right now so it doesn't get out of hand. But again, I'm not a big fan of what we've got there for layout. And yes, I did check the polarity. So this is this trace, that's a little buffering to the power VCC. Actually, that's not VCC. Would it be VCC? I'm facing this way. Yeah, that's VCC smoothing. So that's a little funky, but I'll set aside my dislike of it and we'll just soldier on. Now we've got some disc caps, 22 picofarad. I think there's only 2 of them. I think it's just one here and one here. But again, they gave me 4. So these are 22s. These are small enough that I won't have to bend them flat. I mean, I certainly like saving space by putting components under the microcontroller, but you have to give a little room for them to actually fit well under the microcontroller. See, my new digital timer that I'm using to time builds also may remind me when it's time to recycle the cameras, so they don't go dead without me noticing it. But probably not. I'll probably still not notice. Again, I don't know why Nikon has a built-in turn off after 29 minutes and 59 seconds, but they do. I'm going to put the timing crystal on now. Again, 12 megahertz. And that is below the caps, so I'm going to use, height-wise, so I'm going to use my locking tweezers to hold it in place, flush against the circuit board, while I solder one leg. I can take it off and get the other leg. So that's all the caps, even though, again, I've got 2 spare caps. And they don't go anywhere. Bless your heart for throwing extra parts that I throw into my bench stock. Now there was the transistors, and they're all the same, fortunately. They're all 9012s. Now, instead of one extra, I'm one short. Ah, there it is. That would have been sad, even though I think I got a bag of 9012s over on the shelf. I think I'll put the IC socket down next, because the switches stick up above that. Notch in the right direction. All the components are safely inside it. Once again, another locking tweezer to hold it firmly against the board while I tack the legs down. I'm kind of excited. I'm getting a new kind of tweezers with ceramic clamping surfaces that I haven't seen before, and it showed up on somewhere or other in a sidebar saying you should get these, and so I ordered them. They may be pretty neat. Okay, we'll speed through soldering the pins on the connector. That looks all good. Now we've got 3 push buttons. The legs on these are kind of beat up. Ouch. That's the wonderful sound of punching leads through your skin. Something you never get tired of. Again, since there's no instructions that I can find on this, I'm not sure why there are 3 buttons, but it should become obvious when we're playing with them. And as I was mentioning before, since since the traces on the board are so clearly visible, you can see which pins on the microcontroller are being affected by the switches, so we can probably figure out what their purpose is simply by what signal they're toggling on the microcontroller. I always like to put extra solder on things like switches and connectors just because they take a lot of mechanical force and the solder is the only thing holding them in place. Then we've got the 6-pin switch, and we'll drop it in. Again, we're using our Austin Ribbon Mike's solder thing with lots of different size holes so we can position parts well if I would do it with that and focus on doing it instead of just talking. And the other thing, it is silicone rubber, so your soldering iron won't hurt it, which is very, very handy. And as always, I'll post a link in the description to where you can get this. It's a good thing to have. You'll notice I'm not even checking to see if this switch is straight. Normally I would, but I'm not too concerned about this little module. It's pretty straight. I'm going to put the button cap on it. So that's on, off. Now let's get the barrel connector. Let's drop that in there. I'm actually going to hold this with my, hold it in place with my pinky finger. See, that's the other thing. This solder thing has a nice slot where you can, if you're not a klutz, you can stick a PCB through there and hold it while you're soldering. Until you've got the first leg in, then lay it flat again and again. A lot of force when you're plugging and unplugging that barrel connector, so you want enough solder that it doesn't break free, or even worse, become intermittent, become kind of loose, and then the power connector and power connection will be intermittent, and it'll drive you crazy when you're trying to figure out why it's not working. Now, that's interesting. They did give us a barrel, one of these barrel buzzers, but I don't know where it would go. Doesn't seem to have any space for it, but that's okay. Now we'll put the LED in. You'll notice I'm trying to not use any more solder. Can I make it? Can I make these 4 connections? Oh, no, I'm going to have to get, there are more than 4 connections. Ah, well, I'm going to have to drag out another piece of solder. So next we'll put the display on the board. And the dots give you the orientation. And now, final piece, the ultrasonic transmitter transducers, because they transmit and receive. That build time was 37 minutes and 51 seconds. So it went together really fast. And now we're going to power it up and see what happens. Plugging it into my USB power supply that I did the video where I tore this power supply down, and I liked it so much that I moved it, put it back together and moved it back on my workbench. Now I'm going to turn this light off, and I'm going to make sure this switch is up while I put power in. Now I'm going to power it up. No, I'm not going to power it up because the viewers who've been paying close attention said, why don't you put the microcontroller in it? So I'm starting the build timer up again. And we'll take this this is 89C52RC. I've used these before. Again, they've got a good bit. They're pretty speedy, and at 64K of embedded flash RAM, they're pretty capable too. I mean, obviously, unfortunately, we can't see the programming in this because we don't have any documentation or even a schematic. But again, if we look at the standard pins for this, okay, that added 50 seconds to the build, so it came out to 38 minutes and 46 seconds. Now we're ready to power it up. So battery power, USB power going in, and we'll press the button, and we've got LED, and our display's reading something, and again, I don't know how far it's reflecting, so I'm going to put my hand out, and there we go. Okay, so it can't read anything now because it's too close to get a reflection. So it's 0.06 something, 0.11 somethings. I don't know what the units are. So it obviously works. Let me turn it around and aim it towards the back of my electronics workbench. That's 0.24 somethings. Now I'm going to start pushing buttons. Well, that button doesn't do anything apparently. I don't see that button doing anything either. Now that did something. I don't know what it did. It acted like it doubled it, but then it stopped reading. So let me see if I can get a sense of what these numbers actually mean. So we're at the 22 centimeter, I'm going to assume it's metric because it is from China and it's a communist country and metric system is communist, so it's got to be metric. So if I go, if that's 20, actually it may actually be millimeters, because I am at 22 right here, and I've moved my card out to the end here, and that's 22. Let's go, so that's 0. Now we'll go 10 millimeters, and that's a tenth. I mean point. Okay, so that's 2 centimeters. So it looks like this place is centimeters. That's 3 centimeters. It's kind of 3 centimeters. It's not super accurate, but that's, let's see, where are we at now? Let me get this, the ends better. And they got to be parallel, that's part of it. Because if they're not parallel, then you're going to get displacement in the reflection. And that won't be helpful for you. So that's 1, 2, 3, 4, 5, 6 centimeters. Let's go out to 10 centimeters. Yep. So this reads in centimeters. Now the next question is going to be how far away, what's the range on these sensors? So let me swing this around this way, so it's aimed at me, and I'm about 36 centimeters away. Maybe these have something to do with sensitivity. And again, that one just goes to 50 and doesn't do anything. I'm not sure what that button does. So I'm going to move back. Can't really see it. 55. I'm going to get something more accurate to hold up to reflect against it. I'll get a board. So with no range, oh gosh, it's going out to 1 meter 25. Now let me bring a board in. No, this is pretty useful. No, that could be fun. You could mount that on your garage for the last couple of feet of parking, showing where your fender is. You could put it in a storage room so you could see where, when you were sliding something back into a rack, how far it'd go. I can see a lot of uses for this. It's a nice little unit. So that's the build, and that's the unit. A really quick and easy build, but it comes out with a pretty useful product. So I'll leave a link to this product page on eBay, and if I find out anything more, because I'm going to go do a little research and see if I can come up with anything on what these buttons do, I'll add it to the end of this video. But if not, thanks for watching.